Perfect. I could have used it as a memo.
I'm just saying that it's never.
Fortune.
Oh, Alex.
Okay, so we are busy with. Okay, so yesterday we were looking at something. What was the last thing we wrote?
We had to do.
Oh, yes. Yeah, I remember that. Okay, so you weren't here. We started on trig. You are going to have to figure it out. Or you can take pictures from yesterday if you want to. Pardon? Okay, it's not difficult. Not what we did yesterday. Okay, that's enough now. So what we did yesterday, we gave you a triangle. You had to find all the things that I asked you to find. I suggested that you actually go write down all your ratios and then find the actual values. So for a sine of theta, my opposite would be 3. My hypotenuse, still 5. Cos of theta, theta is my adjacent over hypotenuse, so it'd be 4 over 5. Tan, still theta, is opposite over adjacent, 3 over 4. Then sine of q is still q, so it's still opposite over hypotenuse. Cos would still be adjacent over hypotenuse, and tan would still be opposite over adjacent. So theta and q were actually the same reference angle and therefore have to be the same answers. Okay, let's look at the second set. I asked for sine 90 minus theta. So here is my 90 minus theta. So now sine would be opposite over hypotenuse, 4 over 5. Cos of 90 minus theta, here's 90 minus theta, there's my adjacent, there's my hypotenuse, 3 over 5. I'll show you the answers now. Tan is opposite my 90 minus theta, which is 4, over adjacent, which is 3. Sine of p, now p is my reference, therefore sine is still opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan would be opposite over adjacent. So there are all the answers that you should have gotten. If you don't understand this, you will struggle with what is to come. Yes, Tora. What did you want to say it's not so cold?
No, but you remember it isn't cold today, no?
Not like yesterday.
Yes, yesterday.
Also, maybe if you didn't have holes in your jeans, it wouldn't get cold. I sound like an old person. Oh, that's wrong with me. Okay, so far what we've done, we've just written ratios. We haven't actually calculated anything. And what we're going to start doing today is actually using sine, cos, and tan to calculate missing values of things. Okay? Before we do that, I'm just going to combine two triangles just to confirm one last time that you know what you are doing. So, drawing the following, please. I want one big upside down right angled triangle. The big triangle PQS is a right angled triangle. And then I also want you to draw an additional triangle by cutting this with an altitude and also 90. So I have a second right angle triangle of PRQ. I want you just to name the side lengths of the following. Sine of S, cos of S, tan of S, and these are all in triangle SPQ. Then I want sine of Q, cos of Q, and tan of Q in the big triangle SPQ and in the small triangle QPR.
Ma'am,
Yes.
in the case of when we do our innovation, what we do normal Euclidean geometry, trigonometry, what's
Not in grade 10 as far as I can remember. But also we haven't set that far. So if we do, then obviously I will do similar kind of examples in class. I don't even know what our final exams are going to be on yet.
So like if we get a triangle, then we'd have to work out the normal trigonometry way, and then like angle and side that we use.
Yes,
So why do you
yes.
like math, a triangle, like a circle, which is rooted in, then you must work both of them out? Would they give us something like that?
Yes, we can give you something that would require trig, but remember it would have to be a 90 degree.
Yeah.
If it's not 90 degree, you would have to use your analytical and Euclidean, yes. So as thing is, as soon as I've taught you something, you're technically allowed to use it at any point. So whatever's easiest for you to calculate.
So ma'am, what is sine?
Opposite over hypotenuse.
Ma'am, when is what, isn't there a holiday, like a week holiday?
At the end of October.
Is it end of October?
Yes, adjacent over hypotenuse. 1 week at the end of October, yes.
Opposite of adjacent.
That's for tan.
Opposite over adjacent.
Yes, for tan. So it's SOH, S-O-H, CAH, C-A-H, TOA, T-O-A. Opposite of hypotenuse, O-H. Adjacent of hypotenuse, A-H. TOA, opposite over adjacent. Tan is opposite over adjacent. So that's what we use to remind ourselves.
Okay.
So now you're looking, for instance, we'll do sine S together in triangle SPQ, so the big triangle. S is my reference, so PQ is my opposite, and QS is my adjacent. So that's what I want, 2-letter. So I'm looking for sine. So yes, S is my reference angle. So there in the big triangle is my opposite, PQ, and SQ or QS is my hypotenuse for sine, which is opposite over hypotenuse. So your adjacent would therefore be PS. In my head, I said hypotenuse. I promise you that's what I thought I said. Thank you for correcting me.
So ma'am, please use the opposite side of
To S, yes, in the big triangle.
Okay.
So remember, I have two sides that touch an angle. This, where S is, where I've made the X, one of them is the hypotenuse. The other one that touches is my adjacent.
So ma'am, did I do this right?
So for S, that's my adjacent and my hypotenuse, yes. For Q, this would be my adjacent and that would be my opposite in the big triangle. But remember, Q also exists in a small triangle. Technically, so does S, but I'm not asking for that. I'm going to write in pen just because it's a thinner tip. Adjacent over hypotenuse. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Okay, I will write the ratios so long. So I'm looking at my big triangle and I'm going to highlight it orange just so that I know that's what I'm looking at. So since S is my reference, this is my opposite, that is my adjacent. So I would have PS over SQ, or QS and SP, whatever, and opposite PQ over PS for my, what is that? Oh, adjacent. Looks like an A. I mean, an O. It is an A. Sine of Q, so now that's my reference angle. So this is now my opposite, and that is now my adjacent. I know it's very small. I'll zoom in now, okay? So that is now my opposite. That is my adjacent. So sine would now become PS, but hypotenuse has not changed, so it is still SQ. I'll zoom in a moment. My cos would be my adjacent, PQ over hypotenuse, which is SQ. Tan would be opposite, which is not that one, it's that one, because I'm looking at the green. PS over PQ. Okay, let's zoom in on that so long. And now I'm looking at my smaller triangle for the next three. So I'm going to highlight my smaller triangle in purple. So my reference angle is Q. So there is opposite, there is adjacent. So when I write down those ratios, I have opposite, which is PR, over the new hypotenuse, RP. Oh, here's my hypotenuse. What am I doing? Hypotenuse, adjacent. Why was I wrong? Where must my hypotenuse always be? Opposite the 90 degrees. You see how changing the triangle actually changed everything. Okay, so it's actually good that I made that mistake, so now you know never to make that mistake. Okay, so my hypotenuse is PQ. My adjacent is RQ. Okay, cos of that angle, adjacent RQ over hypotenuse PQ. And lastly, tan would be PR for opposite and adjacent, which is QR. So there is your final answer. So we can ask you this kind of question where I throw triangles with triangles, and you need to constantly shift. Check your hypotenuse and then constantly shift your adjacent and your opposite. So hopefully now that I made that mistake, You won't in future. Ignore this. I was being stupid. Okay.
And can you move the last one up a little bit?
Henry. No, the letters, no. As long as the two letters are the correct letters. So we're supposed to, out of etiquette, put them in alphabetical order, but I literally just wrote down what I saw first. Now, we are actually going to use this information that we have just done, and we are going to start calculating things, because this is still just identifying. And yes, identifying is important, but we need it to be able to calculate. So let's just find some nice ones. So we are going to start with acute triangles. So when I talk about acute triangles, I'm talking about angles that will be less than 90 degrees. Okay, it is still a right angle triangle. So both of them would be acute angles. Okay, taking this off the board now. Okay, so we are now going to calculate angles given the sides. Is that what we're doing first? Now, giving you the angle, we're going to find the sides. Okay, given the angles. So firstly, we're doing calculations. I'm going to give you the size of the reference angle. If I give you the size of one angle and I know that it's a right angle, can we find the third angle? So I give you an angle, the other one's 90. Can I find the third one? Yes, of course I can, because it's a triangle. Okay, so I'm giving you the size of a reference angle. What I'm asking you to do is to calculate the ratio. Now, everything that we've done has been in a nice fraction form, right? 4/5, 3/5, what are the other ones? 4/3. But if we actually had to write them as decimals, we would see that 3/5 is actually not such a nice, okay, 0.6 is a nice decimal. But I mean, you can see that it does have a decimal form, right? So I could have gone, 3/5 was the most retarded one we had. Let's say I had something weird like 66/99. Okay? No, not 66/99. So 66/75 is fraction form, but decimal form at 0.88. So I know what that ratio symbolizes. I know that if it was cos, it would be adjacent over hypotenuse, but the ratio can simplify to a decimal. And that is what we are going to be looking at now. So if I give you the size of the reference angle and I want you to determine the ratio, you are going to be getting it in a nice fraction form if it's a nice angle. Also, it could be a weird decimal, okay? So I'm not asking you to specifically say what the adjacent is and specifically say what the hypotenuse is. I want the simplified ratio as a number, and that is what we are going to calculate now. So what I do, I have to calculate the ratio by pressing on my calculator. You can't do trig without a calculator. Well, you can't do all the trig without a calculator, okay? By pressing on a calculator your sine, cos, or tan button, okay, so they are here, sine, cos, and tan. So you press it, you'll see that it opens a bracket. Okay, so that's the first thing. Second thing, type in your angle size. So let's say I'm going for 67. Okay, still in the acute angle. I close and I press equals. And that is it. The answer that I get is the answer you write down, and that's your mark. The answer that you got, Zora? 0.92. That means whatever the adjacent hypotenuse ratio is will simplify as a decimal to 0.92. Therefore, just hold on, the decimal is the answer in decimal form of your ratio. So the decimal that you get, which will almost always be a decimal, sometimes you're lucky and it is a fraction, is the decimal form of your ratio. Because remember, every fraction can be converted to a decimal. We would need more information to get the true value of adjacent and hypotenuse, but that's not what I'm asking here. I'm just asking for that simplified ratio as a decimal. So I hope you all have calculators because we're going to practice. Chardonnay, do you have sine, cos, and tan on that calculator? Okay. Most of you I know have Casios. Yes.
What is sin and tan and cos equal to?
Depending on the degree that you're looking at, will be different values.
Because what if you don't have a calculator, you have to work it out?
Then you can't. There are 4 special angles that you can learn off by heart, but the rest you can't. So that's why I'm saying you send me a message and you ask for a calculator. Okay. And if I haven't found you, you've asked that teacher to find me and I'll bring you a calculator. But I only have 2 calculators, so you better ask early. Okay. So as far as pure maths goes, and even more so in maths literacy, the calculator is the most important part of maths. Because yes, there's a lot that you can do in your brain, but there's a lot that you can't. So we're going to practice. You're literally going to press the function that I ask you, type in the angle that I give you, and you're going to round off to 2 decimal places for me, please. Okay, so exercise. I'm making things up. I'll show you in a moment. Choose a number less than 90, Chardonnay. Can have decimals.
72.
Keegan?
54.
Matthew?
9.
Henry? Put some decimals in, exactly.
47.
Can you make it a little bit bigger?
Like what do you mean?
Like add a whole number and then a decimal. 17, comma.
1.
Okay. Jordan?
58.9.
Aaron?
29.6.
Zora?
53.6.
Okay. Ayanda?
59.6.
Veli? Okay. Typical. And then Matthew, right on top.
48.
And do you want sine, cos, or tan? You said 48,8. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Get calculating, please. Literally type it in. 2 decimal answer, please.
What's your calculator? Only one, everything.
All of them. Calculating all of them. Practicing that calculator work.
So when we just type in that number where it's on.
Yes. So this represents opposite over hypotenuse of a reference angle 36.5.
Can we put the value?
It should give you answer anyway.
Is that correct? No?
Yes. So I want 2 decimal places, please. So we're also practicing rounding while we're at it. Yes. Hypotenuse. I think. I've never used that button in my life. I have been through university maths. I've also not used the ones with the colons and stuff.
Remember the colon? Isn't that
As far as I know, it's time or longitude and latitude.
good?
Yeah.
Remember last time the father said that is when you're doing raindrops. Well, it's called the Brown-Bayes method.
Oh, I've also not used. No, that's shift factorize.
Oh.
But the actual number without the shift, I don't know what it does. I think it's longitude and latitude, but I could be wrong. Should at least be on the 4th one by now. And I'm going to freeze, so while I start calculating, you can see what I'm writing. Okay, I'm done. And I started after you, so you should be done too. Okay, checking those answers. Remember 2 decimal places. 0,59, 0,31, 2,05, 0,16, 0,31. Going to the top on the other side. 1,14, 0,52, 0,49, 1,36, 0,86, and 0,36. Sine 59.6, 0,8625 is what I get. So it'd be 86. Okay, what do we notice about sine and cos? And those numbers that we got. Pardon?
I said usually never follow one.
It never goes higher than 1, right? Because they are all 0, somethings, okay? That is something that you should have noticed. And when we do the trig functions, you'll see why that is, okay? Whereas tan can be a number bigger than 1, Okay? And also, if you think about it, I'm always dividing by hypotenuse, which is my biggest value, right? Which means I'm never going to obtain a number 1. I'm always going to land up a decimal. Whereas with my tan, if my opposite is bigger than my adjacent, I'm going to get a number bigger than 1. My next question to you is, what I wanted, it's a statement. What this represents, before you pack up, is that sine we know is opposite over adjacent. Opposite what? Opposite over hypotenuse. Okay. My reference angle is 36.5. And that opposite over hypotenuse will simplify to 0.59. So it is still representing opposite over hypotenuse, but now I actually have an answer for what that is. So tomorrow we're going to look at what happens when you get given the ratio, but you have to calculate the angle. Okay, let's pack up.